Hi, Mrs. Sweetie back for Unit 6 video lesson number 13 on gas mixtures. So the key question here is, how is the total pressure of a mixture of gases related to the partial pressures of the component gases? Well, you can have like the air. The air has many different gases in it, and so the air pressure is made up of the partial pressure of each one of those gases that makes up the air mixture. And so that is what we're going to investigate in this video lesson. Particles in a mixture of gases at the same temperature have the same kinetic energy. That is, they are moving with the same amount of speed and the same amount of average kinetic energy or temperature. The contribution each gas in a mixture makes to the total pressure is called the partial pressure exerted by that gas. The total pressure of dry air is the sum of the partial pressures of the component gases. So take a look at this. The total pressure, air pressure, is 101.32. But what makes up that pressure? Well, you have the pressure of nitrogen, the pressure of oxygen, carbon dioxide, argon, and other gases is what makes up the pressure at standard temperature, 101.32 kPa. Dalton's law of partial pressure states that at constant volume and temperature, the total pressure exerted by a mixture of gases is equal to the sum of the partial pressures of the component gases. And here's the equation. So you have the total pressure is equal to the partial pressure of gas 1, 2, 3, and as many gases as you have that makes up the mixture. So let's take a look at this problem. Air contains oxygen, nitrogen, carbon dioxide, and trace amounts of other gases. What is the partial pressure of oxygen at 101.30 kPa of total pressure if the partial pressures of nitrogen, carbon dioxide, and other gases are 79.10, 0.040, and 0.94 kPa respectively? List your knowns. So we have the pressure of nitrogen, the pressure of carbon dioxide, and the pressure of the other gases. The unknown, and the total pressure, is also 101.30. We want to find the pressure of oxygen, and so our equation, the total pressure is equal to the pressure of oxygen plus nitrogen plus carbon dioxide plus the pressure of all the others. Rearrange Dalton's law to isolate the pressure of oxygen by itself. And so what are you going to do? Well, you're just going to subtract all of these from the total. So our equation will look like this. The pressure of oxygen is equal to the total pressure minus the pressure of the nitrogen, carbon dioxide, and the pressure of the other gases in the air. Plug in your numbers, add and subtract, and your pressure of oxygen is equal to 21.22 kPa. And that is the end of Unit 6. This is Mrs. Wethy. Be happy, have fun, so long until Unit 7.